Hey everyone, welcome to Cloud Techie. Today is day 15 of Cloud Techie, and today my topic is Azure Identity and Governance. So when I teach Azure Governance, I do not start with the portal because the portal just makes everything look like a collection of separate plates. Users are in one place, role assignments are somewhere else, and policies are somewhere else. Budgets in another area, and after a while, it feels like Azure Governance is just the list of features, right? Um, that is not the right mental model. A real Azure environment becomes difficult to manage because small decisions accumulate. And let's say if someone gets a contributor at a subscription because the project was urgent, a resource group is created without a naming standard because it was only a test, then a public IP is deployed in the wrong region because nobody had a policy in place yet, and production database is almost deleted because there was no lock. Costs rise because tags were optional, and optional governance usually means no governance. So in this session, I want to explain Azure identity and governance the way an administrator or a solution architect actually uses it. We will start with identity because Azure first know who is making the request. Then we will look at RBAC because identity by itself does not grant permission. Then we'll connect that to scope, management groups, subscriptions, resource groups, Azure policy, logs, tags, budgets, and advisor. Here is the mental model I want you to keep for the rest of the session. Every Azure request goes through a chain of questions. First, who is asking? That identity may be a human user, a group, a service principal, or a managed identity. In Azure, the identity comes from Microsoft Entra ID, right? In second is, what is that identity allowed to do? That is where Azure role-based access control comes in. Microsoft Learn defines Azure RBAC as the authorization system built on Azure Resource Manager, and the important formula is principal, role definition, and scope. Third, where does the permission apply? This is where many admins make mistakes because the same contributor role assigned at a resource group assigned at a resource group is a contained permission, while the same role assigned at a subscription becomes a much larger blast radius. Fourth, even if the user has permission, should the platform allow the resource to exist? That is the job of Azure Policy. Policy is not asking who the user is, it is evaluating whether the resource configuration follows the rules of the organization. Finally, once the environment exists, how do we keep it understandable? That is where tags, budgets, advisor, and logs become operationally important. If you remember this order: identity, authorization, scope, code rails, and operations, the topic starts to feel much less random. Before we talk about RBAC or policy, we need to be clear about what Microsoft Entra ID is doing in this architecture. In an on premises Windows environment, many admins think about Active Directory domain services, domain controllers, Kerberos, LDAP, and of course, group policy. Those are still important skills, but Azure administration starts from a different control plane. Microsoft Entra ID is the cloud identity provider behind Azure and Microsoft M365 sign-in. It holds users, groups, enterprise applications, service principals, and managed identities. When someone opens the Azure portal or runs Azure PowerShell, they authenticate to Entra ID and receives a token. That token is then presented to Azure Resource Manager when they try to manage a subscription, a resource group, or a resource. That separation matters because authentication is not authorization. Entra ID can prove who the user is, but Azure still has to decide what the user can do. That decision happens through Azure RBAC, and depending on the request, can also be affected by Azure Policy or logs. A clean governance design therefore starts by getting identities and groups under control, because every permission assignment later depends on those identities being accurate, owned, and maintained. When Microsoft Learn talks about creating and managing identities, the beginner version is usually about creating users and groups. That is necessary because in a real organization, the more important idea is the life cycle. An identity is not just created once, it joins the organization, receives access, changes roles, maybe becomes a guest or a vendor, sometimes needs password recovery, and eventually leaves. So, if your Azure role assignments are attached directly to individual users, every one of those changes become manual cleanup. That is why a mature design uses groups as the access layer. You might have a group for virtual machine operators in a specific subscription, another group for network readers, another group for application owners on one resource group, and a very tightly controlled group for subscription owners. Self-service password reset fits into the same operating model. So self-service password reset is also known as SSPR, and it is not just a convenience feature, but it reduces helpdesk dependency and helps user recover access in a controlled way, provided authentication methods and registrations are configured properly. The practical message is that Azure governance begins with identity hygiene. If your users, groups, guest, and service identities are unmanaged, RBAC will look clean in a diagram but becomes very messy in production. Now we need the hierarchy because Azure governance is mostly about inheritance. At the top, you have the tenant and the tenant root management group, as you can see in the diagram here. Under that, you can create management groups to represent the structure of the organization. Below management groups are subscriptions, and below subscriptions are resource group and resources. Microsoft Learn describes management groups as a governance scope about subscriptions, and that is a key phrase. They allow you to apply access, policy, and compliance controls once at a higher level and have those controls cascade down to the subscriptions underneath. This is extremely useful when an organization has many subscriptions. Instead of applying the same allowed location policy to 20 subscriptions one by one, you assign it to the management group here that contains those subscriptions. And a resource group usually should normally represent a lifecycle boundary. If resources are deployed, updated, and retired together, they often belong together. So when you hear a management group, subscription, a resource group, and a resource, do not memorize them as a list. Think of them as co-ops where governance decisions inherit downward. Azure RBAC becomes much easier once you stop thinking of it as a list of built-in roles and start thinking of it as a role assignment. Microsoft Learn is very precise here. I'll pin the articles in the description. You can check them out. And from the Microsoft Learn article, it says that a role assignment consists of a security principle, a role definition, and a scope. The security principle is the identity that receives access. It can be a user, but in a healthy environment, it is often a group, a service principal, or a managed identity. The role definition is the collection of allowed actions such as reader, contributor, owner, virtual machine contributor, or a custom role. The scope is where that permission applies. This is usually where the real architecture decision happens, and if the application ops team only needs to manage virtual machines in one application resource group, giving them contributor at the subscription is not efficient. It is just lazy and risky. A better design is to assign the group a more specific role at the resource group scope. That way, they can do their job without gaining accidental access to networking, shared services, or other application environments. So when a user says that they cannot create a resource or they can see a resource but cannot modify it, your troubleshooting starts by checking those three pieces. Who is the principal? What role do they have? And at what scope was it assigned? Scope is where Azure RBAC becomes either elegant or dangerous. The same role definition can have completely different consequences depending on how or where it is assigned. Honor at a single resource group is already powerful, but honor at a subscription means the user can manage access and resources across the entire subscription. Contributor at one resource is a narrow permission, while contributor at a management group can affect many subscriptions underneath it. That is why I like to describe scope as blast radius. You're not only deciding what a person can do, but you're deciding how far the effect of that permission can travel. Microsoft Learn also points out that Azure RBAC is additive, which is a detail administrators need to understand for troubleshooting. If a user has reader at one resource group and contributor at the subscription level contributor assignment gives them broader permission across the subscription. The reader assignment does not reduce that. So when someone appears to have more access than expected, do not look at only the resource. You have to walk upward through the hierarchy and check assignments at the resource group, and resource group, subscription, and even the management group levels. In real operations, the clean pattern is to assign roles to groups and prefer the narrowest useful scope, review high privilege assignments regularly, and avoid using on as a convenience role. So this is the difference between RBAC and Azure Policy, and it is one of the most important distinctions in AZ-104. RBAC is about authorization. It asks whether this identity has a role assignment that allows the requested action and the requested scope. Azure Policy is about governance. It asks whether the resource configuration follows the rules of the organization. For example, a user may have contributor access to the subscription, so RBAC says they are allowed to create a virtual machine, but if an Azure Policy assignment says virtual machines can only be created in Canada Central and Canada East, then a deployment to West US can be denied even though the user has contributor role. That's not a permission problem. That is governance guardrail working as designed. So Azure Policy can audit, deny, modify, append, or deploy related configuration depending on the effect. Initiatives group multiply policy definitions together, which is how organizations apply a security baseline instead of managing one role at a time. A single subscription is easy to govern manually, but imagine you have 10 subscriptions and that is not at all easy to manage, right? And think about 50 subscriptions. Just become impossible if every policy assignment, role assignment, and exception is handled one subscription at a time. That is why management groups exist. They give you a level above subscription where you can apply governance consistently. A common structure is to have management groups for platform services, landing zones, production, non-production, sandbox, or business units. The exact design depends on the organization, but the principle is the same. Put subscriptions with similar governance requirements under the same management group, then assign policies and access at the level where they make sense. For example, a policy that restricts regions for all corporate workloads might belong high in the hierarchy. A structure policy that blocks public IPs might apply only to production landing zones, and a platform operations group might need rigor across all landing zones, while an application team might only need a contributor on one application resource group. After identity, RBAC, hierarchy, and policy, we still need the operational layer. And this is where logs, tags, and budgets in, of course, Advisor comes in. Resource logs are there to prevent accidental deletion or modification of critical resources. Microsoft Learn is very clear that logs are different from RBAC because a log applies a restriction across users and roles. So even if someone has an on role, a cannot delete log can block deletion at the control plane. That is useful for production resource groups, critical networking components, and shared services. But you also need to understand the side effects. A read-only log can block operations that look harmless, but many Azure operations use post requests. Tags solve a different problem. Tags do not protect resources by themselves, but they make the environment understandable. If every resource has owner, application, environment, cost center, and data classification tags, reporting and cost allocation becomes possible. Budgets are part of financial governance. They allow you when spend crosses your threshold, but they're not a hard technical stop on resource consumption. Azure Advisor completes the picture by giving recommendations across cost, reliability, security, operational excellence, and performance. Now, let me put this into a practical scenario because this is where the topic starts to stick, right? Imagine your department asks for a new Azure environment for a customer facing application. The beginner response is to create a resource group and start deploying. The architect response is to ask where does workload belongs in the operating model. Like, do we need a separate subscription because of billing, isolation, or ownership? Which management group should it sit under so it inherits the correct baseline policies? Which team needs access? What is the smallest scope where those teams can do their job? Does the application team need a contributor on the resource group, or do they only need specific roles for app servers, storage, or virtual machines? What policy should apply before anything is deployed, such as allowed regions, required tags, diagnostic settings, or restrictions on public exposure? This slide is very important for troubleshooting. Let's say someone is trying to create a VM and they cannot create the VM. So of course you first check the permission, but most of the cases permission might be the problem, but you have to check if there's a Azure policy assigned. Sometimes there might be a lock, or there might be a policy that prevent the user from creating the VM in the specific region, or there's a restriction inside, so you have to check that too. Sometimes could be because the policy requires a tag to be applied or diagnostic setting to be applied. If a user can read a resource but cannot modify it, that may be because they only have the reader, but it may be also because a read-only lock is applied to the resource group. If you're studying for AZ-104, Microsoft expects you to know the individual services and the decisions around them. You need to know what Microsoft Entra ID is, how users and groups are managed, what SSPR does, how Azure RBAC works, what role assignments are made of, what management groups are used for, and how Azure Policy Initiative enforce standards, how subscriptions, resource groups, logs, tags, budgets, and the advisor fit into governance. But if you want this knowledge to stay in your head, do not store it as disconnected definition. Store it as an operating model so that you would know identity proves who the caller is. RBAC decides what that caller can do. Scope decides how far that permission can go, and management groups let you apply governance across subscription. When it comes to Azure policies, policy defines what resource configurations are allowed or audited. In logs protect critical resources from accidental control pane changes. Tags make ownership and cost visible. And budgets create financial alerting, and advisor helps you to continuously improve the environment. And this is the full picture. When you hear the word governance in Azure, do not think of paperwork, think of a control scale. Governance is how an organization let teams move quickly without letting the cloud estate become an expensive, insecure, and undocumented mess. These are the official Microsoft references I use to build a session. If you're preparing for AZ-104, start with Manage Identities and Governance Learning Path. Then use the RBAC management groups, Azure Policy, logs, tags, budgets, SSPR articles when you need implementation details. So Microsoft Learn can feel dry when you read it end to end, but which is why this session translates the material into an operating model, but the documentation remains a source of truth for exact behavior, especially when you're validating a design or preparing for an exam.